Hi everyone, my name is Gal Barnea. I run the partner engineering team at Amazon Redshift. And welcome to my reInvent session, migrating a legacy data warehouse to Amazon Redshift. When it comes to migrations, it's all about speed of innovation. By migrating to a modern data warehouse in Amazon Redshift, you'll be able to create actionable insights for your users. You can answer your internal and external customers' requirements faster, introduce new datasets, and enrich existing ones quicker, and open up new ways to analyze all your data. You will be making your customers' experience better, and you can evolve your product in more meaningful ways, which allows your business to continuously make progress and grow. Today, we will discuss the reasons customers and potentially your own company are looking to migrate from your legacy data warehouse. We'll highlight new features that can help you accelerate your migration. We'll share best practices and guide you on how to start your migration today so you can benefit from the value of a modern data warehouse. Take, for example, Intuit, a business and financial software company that had a solution based on SQL Server but couldn't scale to meet the growth of data fast enough, which resulted in delayed insights. Once they migrated to Amazon Redshift, they were able to scale with zero effort. Performance grew 20 times faster, and both time to insight and cost dropped significantly. And Intuit are not alone. Redshift continues to be the most popular cloud data warehouse with tens of thousands of customers. Many of those customers, some are highlighted here on the slide, have successfully migrated their workloads to Redshift and see similar benefits. If you have a legacy data warehouse today, you probably know that many times data from different lines of business and source systems is siloed, and sharing or querying data across those boundaries impossible, and leads to lack of data visibility across groups and organizations. It's a real challenge. With a modern data architecture, you can combine all your data and query it in place to generate meaningful cross-organizational insights. The Lakehouse approach allows you to do just that. A data warehouse that lives with one leg in the data lake and allows querying its data in place with no additional processing needed. And it's not just that. A modern data warehouse needs to answer a variety of requirements. Your users, for example, may be looking to perform predictive or operational analytics in addition to classic ad hoc queries. Your data administrators and owners want a single data catalog that is comprehensive and searchable, in addition to industry-leading security and compliance that doesn't require any additional costs. And your data engineers are looking for a broad ecosystem to ingest data, transform it, and the ability to automate infrastructure through code. Let's dive in and learn how a migration to Amazon Redshift looks and the tools and services that can help with it. Migration of a data warehouse is a journey, and the first step is always the most challenging. Sometimes we find organizations can get paralyzed if they can't figure out how to move each and every last workload. There's no need to boil the ocean when it comes to migrations. For many of you, an iterative approach would be the right one, and one we encourage you to take. We often work with organizations to build a three-phased plan. In the initial step, we analyze the existing systems in place, the business use cases and workflows that enable them, and we also grow the organization's expertise through in-person or virtual enablement sessions. The next step is focused on a pilot. We identify a key workload based on the business needs. We build a target environment, and we migrate it while enabling the ETL and BI tools to operate in dual mode, supporting both the legacy and a modern data warehouse, the target one. This step is key, not just because the business is starting to see the benefits of a new environment, which I mentioned, but also because we are also establishing the team's skills and putting in place a center of excellence for the next iteration. From here, we transition to the third step. We continuously migrate workloads by workload. Based on a business priority and use cases, we migrate, test, monitor, and optimize. Through this incremental approach, shareholders see, I'm sorry, I missed that word. From here, we continuously migrate workload by workload. Based on a business priorities and use cases, we migrate, test, monitor, and optimize. Through this incremental approach, stakeholders can see increasing benefits from the initial stage. And together, we can de-risk a lot of the uncertainty that comes with a large migration. From a technological perspective, we start with data. AWS provides the broadest range of tools for easy, fast, secure data movement to and from AWS Cloud. But I'd like to highlight two key services that we built specifically to help accelerate your data warehouse migration. The first one is AWS Schema Conversion Tool, SCT, which accelerates migrations by automatically converting the source database schema and a majority of the database code objects, including views, stored procedures, and functions, to a format compatible with the target database. During this process, SCT generates detailed migration reports, performs cloud-native code optimization by converting legacy functions to their equivalent AWS service, thus helping you modernize the applications at the same time of database migration. Once schema conversion is complete, SCT can help migrate to Amazon Redshift using built-in data migration agents securely and in parallel. The second service is AWS Database Migration Service, DMS. It's a service that helps you migrate databases to AWS quickly and securely. The source database remains fully operational during the migration, minimizing downtime to applications that rely on that database. DMS is highly resilient and self-healing. It continually monitors source and target databases, network connectivity, and the replication instance. In case of an interruption, it automatically restarts the process and continues migration from where it was halted. Multi-AZ option allows you to have high availability for database migrations and continuous data replication by enabling redundant replication instances. With DMS, you can continuously replicate your data with high availability and consolidated databases into a petabyte scale data warehouse by streaming data to Amazon Redshift and Amazon S3. We designed AWS Database Migration Service, DMS, to be simple. You can get started in less than 10 minutes. And just as important, you can use DMS for free for 6 months. We touched on data movement, schema migration, and replication. Now let's look at Amazon Redshift and the innovation the team has been driving. Over the last few months and at reInvent, we've released many new capabilities to provide new users and existing ones with the experience that exceeds their expectations. We're expanding to new use cases and solving machine learning problems such as predictive maintenance and fraud detection. We're also enabling customers to share their data across clusters using live data with our new data sharing feature. For those of you that are managing the databases, you'll benefit from the fact that Redshift is a self-learning data warehouse that automatically optimizes performance based on your workloads. So you don't have to worry about tuning, patching, or backups. It's easier to get insight with a fully managed system. With the RE3 nodes with managed storage, you can scale compute and storage independently as well. There's a lot here, and I won't talk about all of them in this session. But there's a few specific ones I'm going to dive into in more details, ones that are geared towards simplifying and accelerating migrations. First of those is support for stored procedures, which allows you to bring existing stored procedures to Amazon Redshift and reduce your migration effort. It supports the PL/PG/SQL dialect and can include variable declarations, control logic, loops, allows raising errors, and supports security definer and other features as well. Unlike a user-defined function, a UDF, a stored procedure can incorporate data definition language, DDL, and data manipulation language, DML, in addition to select queries. You can use procedural language, including looping and conditional expressions, to control logical flow. It also provides a mechanism for fine-grained access controls, since you can create stored procedures to perform functions without giving user access to the underlying tables. Say, for example, that only a super user can truncate a table, and the user needs write permissions to insert data into that table. Instead of granting user permissions to the underlying table, you can create a stored procedure that performs the task. You then give the user permissions to run the stored procedure. Many customers already use Redshift table-level access control for data in Redshift, and also want the ability to control access at a finer granularity. With column-level controls, you can control access to columns without having to implement views-based access controls, or use another system. It allows enforcing security for sensitive data, such as PII or PCI, by granting and revoking column-level privileges to a user or a user group. Take this example, where we grant permission on sensitive data to an authorized user, while revoking one to the unauthorized user. As the authorized user, they're able to select star from the sensitive table, as well as call specific columns in their select query. They both are successful. As an unauthorized user, though, doing select star returns an error. However, when trying to select column that they are permitted to, they are successful. Recently, we announced support for up to 100,000 tables and 20,000 stored procedures. Until then, customers with more tables had to split their tables across Redshift clusters or move some tables to Amazon S3. Now customers can migrate their workloads without splitting or moving their tables. This capability is automatically enabled for all supported node types: DC2 8XL, DS2 8XL, RA3 4XL, and RA3 16XL for existing and new clusters. So you don't need to change your workloads, data ingestion, or your application to take advantage of this feature. Worth noting that the limit includes user-defined temporary tables and temporary tables created by Amazon Redshift during query processing or system maintenance. Amazon Redshift launched native spatial data processing support at reInvent last year with a polymorphic data type, geometry, and more than 40 SQL spatial functions. We've worked with customers during their migrations and extended the support with over 30 new spatial functions, such as validation, simplification of geometries, new spatial relationships like crosses and contains properly. Furthermore, Amazon Redshift enhanced the spatial functionality with multiple capabilities, such as support for importing spatial data, and it can now be ingested from shapefiles stored on Amazon S3 by using the copy command. The JDBC and ODBC driver support for the geometry data type enables seamless connection to a spatial ecosystem, and customers and partner applications can natively consume spatial data now. New spatial predicates and functions enrich the spatial feature set, and performance optimization enable customers to dive deeper into advanced spatial analytics with Amazon Redshift. Many of these additions will simplify migrations from data warehouses such as Teradata and provide a one-to-one migration path that was previously challenging. We've recently added native support for time and time TZ data type. Time data type stores the time of day without time zone information, and time TZ stores the time of day including the time zone information. This new data type builds on the existing support for Amazon Redshift for date, timestamp TZ data type that can store data and datetime values. You can also use various datetime SQL functions to process the time values in Redshift queries. Time and time TZ stores UTC values with up to 1 microsecond resolution and are sized at 8 bytes. The next upcoming exciting feature is native support for semi-structured data, now available in preview. We've supported reading JSON file formats using Redshift Spectrum, but we've also consistently received requests to query nested data, such as JSON, natively in Redshift. Today, we've introduced a new data type, Super, that will support these nested data formats, such as JSON, and enable customers to ingest, store, and query nested data natively in Redshift. JSON formatted data can be stored in super columns. The super data type can be queried through an easy-to-use SQL extension that is powered by the particle language, a query language which is designed to seamlessly process structured and semi-structured data. Particle extends the standard SQL language to declaratively express and process nested and multi-value data, and is being actively adopted by multiple AWS services, such as Amazon S3 Select, Amazon Glacier Select, and Amazon Quantum Ledger Database, QLDB. Customers have also access to have the flexibility to integrate with other AWS partners and services. Lambda user-defined functions, UDFs, enable you to use an AWS function as a UDF in Amazon Redshift and invoke it from Redshift SQL queries. This functionality enables you to write custom extensions for your SQL query to achieve tighter integration with other services or third-party products. For example, you can write Lambda UDFs to enable external tokenization, data masking, identification or de-identification of data by integrating with vendors like Protegrity, and protect or unprotect sensitive data based on a user permissions and groups in query time. Amazon Redshift Lambda UDFs are architected to perform efficiently and securely. When you execute an Amazon Redshift Lambda UDF, each slice in the Amazon Redshift cluster accumulates the applicable rows of arguments and sends those rows in batches to your AWS Lambda function. The number of parallel requests to Lambda scales linearly with the number of slices on your Amazon Redshift cluster and performs up to 10 invocations per slice in parallel. Another important aspect of Lambda UDF is that they can be written in any of the programming languages supported by AWS Lambda, such as Java, Go, C++, C, and Ruby, which provides an additional path to porting complex functions and macros from your current legacy data warehouse. Amazon Redshift continuously monitors user workloads and uses sophisticated algorithms to find ways to improve the physical layout of data to optimize query speeds and tune queries. By using automation to tune the cluster, customers can decrease administrative costs for Amazon Redshift while getting the best possible performance. Our new automatic table optimization feature selects the best sort and distribution key to optimize performance for the cluster's workload. If Amazon Redshift determines that applying a key will improve performance, tables will be automatically altered without requiring administrator intervention. Additional features such as automatic vacuum delete, automatic table sort, and automatic analyze eliminate the need for manual maintenance or tuning of Redshift clusters to get the best performance. During a migration, these would allow you to focus on application side and business-facing challenges. Still, these automation features are optional, and you prefer to have fine-grained controls over performance and tuning, you can continue to do so. I would like to take a bit of time and share a few best practices and guidelines when it comes to migrating to Amazon Redshift. Sizing of a Redshift cluster based on an existing legacy data warehouse is always a challenge, and many consider it more of an art than a science. So in order to help those customers, we've built a sizing widget in the Redshift console. As you can see here, the sizing widget allows an interactive, more intuitive way to size the cluster based on whether your data is compressed or not, whether your data is added in time order, meaning added every month, or week, or day, and the amount of data that is frequently queried, meaning hot data. In order to help you improve the performance and decrease the operating cost of your Amazon Redshift cluster, the Redshift Advisor within your Redshift console offers you specific recommendations about changes to make. Advisor develops its customized recommendation by analyzing performance and usage metrics for your cluster. These tailored recommendations relate to operations and cluster settings. To help you prioritize your optimization, Advisor ranks recommendation by order of impact. And again, it's available on your Redshift cluster console. In the next few slides, we've listed additional best practices and considerations that are valuable for a migration. I won't discuss each and every one of them, but call out a few, if that's fine. One example, LOBs, large objects, that hold such as images and PDFs, can be still ported with the help of SCT to S3, with a link or pointer stored in the Redshift tables. Or for example, using materialized views to help migrate complex queries and provide faster query performance for your BI dashboards. When migrating your ETL data processes, there are a variety of paths you can take. One is modernization approach with native AWS services, while another one, just as compelling, is to leverage existing partners, such as Matillion and Informatica, that support Redshift natively and allow you to change your target type and point your workloads to a new cluster endpoint, and maintain all the transformations and business logic that have been built into them by the team. For a Vertica migration, and you can see 3 successful migrations examples here, you can simplify ETL queries, creating UDFs with the same signature as Vertica specific ones. For a Netezza or Greenplum migration, you can take advantage of native bulk export for fast data and onboarding into your data lake or into your data warehouse. And for an Oracle or a SQL server, it's worth mentioning that OLTP workload can be migrated to AWS RDS or Amazon Aurora and still be queryable from the Amazon Redshift cluster endpoint using Amazon Redshift federated queries, which distribute the computation directly into the remote operational database and uses its parallel processing capacity to support running these queries as well. So now you probably ask yourself, that's all great. How do I start? Working with one of our data warehouse migration partners can get you up and running quickly and help ensure you are using best practices and tools. Our partners have deep understanding of Amazon Redshift, will accelerate moving a data warehouse to the cloud with proven best practices and resources, and have proven success delivering AWS services to customers. We have many of those partners. Some of them are listed here. You can see the full list on the website. Last but definitely not least is our main migration hub on the Amazon Redshift public website, which is the best starting point. And I encourage you to visit it, learn more about Amazon Redshift and new features. Many are coming in the next few months. You can also hear migration success stories from customers and partners. And most important, you can talk to a migration specialist that can provide you with an in-depth analysis of your potential migration paths and help you throughout your migration journey, which I have no doubt would be successful. I'd like to thank you for attending the session. Please feel free to reach out to me. My email is here on the slide with any questions or feedback or general requests. I'd be more than happy to help. Have a great day and all the best.